Right. The almighty bearing is finally upon us. Yes. I told us from the onset that the essence of looking at Pythagoras theorem, the cosine rule, and the sine rule was because I wanted us to get to this point, and finally we are at our destination, bearing. Why am I so much interested in this topic? I found out that so many students are scared of this. Yes, I was a victim. I dreaded bearing when I was in secondary school because I didn't understand how to go about it. So the key to understanding bearing is having a teacher who has the orientation, who has the awareness, and who has what it takes to be able to give you a breakdown, a stepwise breakdown of how to tackle the problem. So that's why I'm here. And after this, I believe that when you see it in subsequent situation, you won't have any problem embracing it. Okay, so stay tuned and let us see how we can solve this problem. And one thing again that you have to understand is that when it comes to mathematics, your level of proficiency in any language in which the question is given is important. If you are using English as a medium of instruction, then you must have some good understanding of English in order to be able to understand the question and then find a way to tackle it. The same way it applies to any other language. All right, so the question says the bearing of A from B is 135 degrees. What is the bearing of B from A? Watch again. The bearing of A from B, that means A is coming from B. Are you getting the point? So you're starting with B. The bearing of A from B, from, that's the key word, from. So we can underline it, from. So it means you are starting with B. Now, this is your B. This is the point B. A is coming from B on what bearing? 135. All right? Before I go here, let's look at the four quadrants. Quadrants. There are four quadrants. Each quadrant is equal to 90 degrees. So from here to here, this is the first quadrant, is 90. Here is also 90. So from this north to this point now becomes 180. From this north to this point becomes 270. And from this north to this, you have what? 360. How did I get 360? Each quadrant is 90. From here to here is 90. From here to here is 90. So I just said 90 plus 90, 180. From here to here is 90. From here to here is 180. There's another 90 here. 180 plus 90 will give us 270. Similarly, on the last part, we have 90 degrees. 270 plus 90 will give us what? 360 degrees. So it's good you understand these cardinal points, or we call it quadrants rather. Right. Now, take this down. All bearings start from the north. I'm going to write it in capital letter. All bearing starts from the north. I know why I put it this way, so that I don't forget it. All right? We're going to label this B now. This is our north pole. This is south. This is east, and this is west. So, using this as a key sentence, all bearings start from where? The north. That's one thing you must not forget. All right? This is our north pole. This is our south. So, we're starting from here. Now, the bearing of A from B, this is our B. So, we're going to look at where A will be standing. Is away from B on a bearing of 135 degrees. So you start from the north, please. Start from here, north. This is 135, it's more than 90, right? So we have taken the first quadrant, which is 90 degrees. We are trying to get to 135. What can I add to 135? What can I add to 90 to make it 135? Yes, mathematicians? What can I add to 90 to make it 135? Well, if you look at it properly, you notice that it is in the second quadrant. And the sum of angle in the second quadrant is what? 180. From here to here is 180. So just say 180 minus 135. Whatever that it gives you become the remaining angle. So that will give me 45 degrees. Now you can draw your line. Anyway you are tired, just drop it. Alright? So this becomes my point A. Did you see that now? This becomes my point A. The question is, find the bearing of B from A. So it means now that the bearing of B is where? At A. Exactly. It's as simple as that. If the bearing of A from B is 135, what's the bearing of B from A? So the bearing of B that we're looking for must be found where? At point A. It's as simple as that. So it means that B is coming away from A on such bearing. What do we do? Remember what I told us? This is 90. This is 180. It comes here. This is what? 270. First quadrant, second quadrant, third quadrant. So we are going to the fourth quadrant. Alright? Now, alternate angles are equal. How do we know alternate angle? Angle Z. Like this. Whenever you see anything like this, the angle here is equal to the angle here. So I can call it AA. Alright? In a similar fashion, if I draw it like this, the angle here is equal to the angle here. If here is A, here is also A. So in that situation now, what can we bring out? Look at this shape here. I have a shape like this. Right? I have a shape like this. Here is 45. It means that here is also 45. So what I need to do is this. Since here is 45, here must be 45. The reason is that what? Alternate angles are equal. That means this side is alternate to this side. Alright? Now sum up everything we have here. 270 plus 45. What will it give us? 30 plus 270, 315. So that will give us from here to here will be 315 degrees. Therefore, the bearing of B from A is 315 degrees. Alright? I don't think it's a difficult thing. So you just write it here. The bearing of B from A is 315 degrees. That's it. The keynote here is that all bearing starts from the north. Take note of that. The northern pole. Alright? If the bearing of A from B is 135, it means that the bearing of A is at what? Point B. Then you are looking for what is the bearing of B from A. That means what is the bearing of B from this A. So the bearing of B becomes where? It becomes located at point A. We're going to encounter more of this problem as we proceed. In our subsequent lessons under this topic, we are going to see more of this example, but this is just a way to start it. All right? Thank you so much. Have a blessed evening.